All right, here we go. Doing this again. First time around, didn't work so well. But I just need to grab the link for this quick. Share around. So bear with me for one moment. We'll see how this goes. Okay. Here we go. Boop. All right. Try this again. Okay, here we go. Okay. There we go. All right. Sweet. We are doing this again. All right, well, let's get into it. So we are back coding on Hanuman, which is our kind of Grafana Lite, if you want to call it that. Not really, but basically just an observability type software. So we're going to take data and attempt to visualize it. This data can be arbitrary. We don't necessarily know ahead of time what the data will be that we're visualizing. So could be anything potentially. Now, for our purposes, of course, we're going to have to kind of find data to work with and test with, which can be, potentially anything. But we're going to talk about that in just a second. So what we did last time, though, we basically got our project set up. Just basic Go backend that at the moment is really doing nothing. We're using the Gin framework for Go for web functionality. All we did is set up a super basic backend. Same thing with the front end. We set up a super basic front end using Next.js. All that is just these two files. Really, we just have one component for our home page, and that's it. Right now, the front end and the back end are completely disconnected, but we're going to get those connected. We're going to talk a little bit, just kind of general architecture of how we're going to build this thing, and also kind of get into the data that we're going to test with. And I have I think a pretty good one picked out, but we'll see how it goes. All right, so first things first, let's talk architecture really quickly. So here's what we want to do. I'm just kind of creating a diagram here. Search shapes. Why are you doing this draw.io? Why are you hiding stuff? That's fine. We'll just kind of go with this. Jeez. Generate. Oh God. We don't need to do that. Wow. Okay, really don't need that. So we're just going to create a quick, basically architectural diagram, just general, to talk about this. And draw.io is killing me, so I'm just going to reload it quick. Let's leave it. Let's just create a new one. Blank. All right, there we go. Draw.io not killing me. So here's what we're going to try and do. Sure, let's do this one, the kind of cartoony laptop. Drag it out here. So we're assuming we're going to have our front end next.js out here. Okay, so we'll have our front end, and essentially we're going to have some bidirectional communication between our front ends. And right here, I'm just using the boxes just for labels. Oh man, there's a whole server rack. Sure. Let's do it like a server tower for this time. And what we're gonna do is hook up our front end with our back end. Golang. Okay. And using these two together, so we'll have the front end in Next.js, back end in Golang. So really though, this really doesn't give us much at this point. We just have like two software packages, but where do we get data? Well, we can get data from different places. And for those of you familiar with Grafana and with a lot of observability type systems, they use plugins. And so we're going to do something similar here. We'll probably start with just one plugin. And in general, we will likely follow the plugin protocol that Grafana uses. The benefit of doing this is that down the road, we can potentially use Grafana data source plugins in our own system. There's a bunch of them out there. And so providing compatibility for that is nice. But we're going to, at first, though, go our own way and do our own thing. We can call it a stretch goal. But we're building things in such a way that the stretch goal should be attainable, at least in an ideal world. Maybe it'll all fall apart. We'll see. So, how this pans out. But just to give a general kind of view of this, let's, this is always what the database is just like these kind of like magnetic disks, even though these days they're very rarely actually magnetic disks. So then we're going to have bidirectional communication between the backend and these different data sources. So let's just say that, for instance, this one might be the SQL database. We might have, let's see API. I don't know if API is actually going to show anything here. API connections, API gateway. So these are all Amazon type things. We're not trying to target specifically Amazon. Sure. Let's just say, I'm not sure what logo this is for what product, but it'll get the job done. So we might have like a logs API that we're going to communicate with. And let's just throw in one more there just for the sake of illustration. What would be a good one? Let's do cloud. Cloud's always good. We're getting data from somewhere in the cloud. Cloud computer, cloud rack, sure. We have a server rack. We're just going to assume that we'll just call this cloud data. Okay, so we have some kind of bi-directional communication in between all these things. We're kind of still fuzzy on the details of how we get there, but we're just kind of assuming that for each of these arrows out here, and let me try and pull this a little bit better. Oh, let's stay on page. Hit the wrong key there. So, kind of get these lined up. There we go. So, we're just going to kind of assume that these are plugins of some kind. Data plugins. Right now, we don't have any plugins whatsoever. We don't even have a plugin system. The way this works in Grafana and like a lot of systems, currently they use, so we're using gRPC, PC, and protocol buffers. Okay, and so essentially these are our network protocols. So when we're talking about data sources as being plugins, these are actually, when it comes down to it, like separate pieces of software. So these plugins that are going to get the data, so log data, all potential. And so we're kind of just getting this flow of data that comes from one of these places, goes to our backend, and from our backend goes to our front end. So we have this kind of clear line of stuff, and potentially, probably not at first, but potentially we can maybe do something with this data and then send data back, depending on what data source it is. Some of these are not going to be manipulatable data, not going to be mutable data. We're just going to be reading it only. But we could say that potentially maybe we can read or modify some of this data depending on what it is and how it's done. But we'll just assume that for future purposes, it's read and write. So it goes both ways. It's bidirectional. Now, in terms of gRPC and protocol buffers, let's just, Google is always our friend here. gRPC is a modern high-performance remote procedure call framework that can run in any environment. So really what this means is that we have remote data of some kind, or potentially like remote functions or procedures, typically like a function. I wouldn't say they're exactly the same, but I think for our purposes, we can treat them as being interchangeable. So basically, we have remote functions somewhere that we can call and get data back from. Simple as that. So I really, we're calling these data plugins, but they could also just be data like programs. So as long as we're getting back the data in a standardized format that we can understand, it could be a plugin, it could be another program, it could actually be written in an entirely different language. As long as we get data back, and as long as we've agreed upon how we're getting that data, which gRPC allows us to do, then we're just fine, essentially. So we're essentially kind of going to be establishing this contract between kind of how the backend will get data from potentially these other programs. And then we'll do stuff on the backend with them, send them to the front end where people will interact with them. Now, of course, right now we only have one front end, but if we're careful about things and if we're smart about things, hopefully we could do something like this too. So again, this is probably more for the future, but just as kind of an example, we're really just setting up a kind of system that allows us to get data to a device on the end. So we could have a mobile device as well. Wow, that's really big. We'll size this down. Oh, good Lord. There we go. Mobile application, and that's nothing right now, so to be determined. So we'll figure that out as we go about and do this. But that's generally, like, from the architectural point of view, kind of what we're looking at doing. And again, we're not really looking at completely like trying to replicate what Grafana has. Grafana is a very in-depth and complex system that has many, many features. We're trying to create a simple system. It's just a good target though. It's open source, so we can, kind of leverage some of these plugins potentially. It's also it's fairly straightforward, but also non-trivial. So we were trying to build something that has a little lift involved that can be potentially useful. But we're trying to come in slimmer. So we're trying to do something a little more lean and mean in this case, which is fine. So like with anything, there are many kind of niches and things for software. So we can be in the same kind of ballpark without kind of stepping on each other's toes necessarily. Okay, so this is out of the way. I'm going to go ahead and save this. The nice thing about this is we're using Draw.io. They use XML files, so we can save these. I'm going to put it in the repository, but call it Hanuman Architecture. Okay, download that. All good. All right, so we have a kind of a general idea of architecture, and we'll see how this goes. This could, as with anything, this could always change, but for now, it should do the trick. So I'm just going to close out of that. I don't think we'll be needing it for the moment. Okay, this too. But before we get coding, what is the data set that we're going to be testing with? What might be interesting? And for me, one of the things that has always been kind of fascinating is geographic data, because it often relates to real places and real things. There's lots of different ways to slice and dice and visualize it. A lot of observability type systems focus more on time series type data, but what can be interesting is focusing on non-time series, so geographic or tabular data. Tabular data is what you'd find in most SQL databases. So we're going to go in that direction. So rather than a time series where you have just data through points in time, which we'll probably try to do down the line as well, we're going to focus more on the geographic tabular side, so things you'd find in your typical kind of SQL or geographic databases. The other part of the reason we're doing this is there's a lot of kind of interesting tabular type data out there. So for anyone who's worked in a lot of businesses and stuff, there's a million CSVs. CSVs are basically just another type of tabular data for the most part. You have just columns and rows, and we want to be able to break those down, and visualize them, analyze them in different and interesting ways. So with that in mind, the data source we're going to use, we want to pick something that's fairly accessible, but also again somewhat non-trivial. So with this, what we're going to do is use Foursquare information. And for those of you who don't know, Foursquare was an application that allows you to kind of check into where you are. They kind of pioneered that concept. But one of the things you need when you're doing check-ins for different places is you need a lot of geographic information. You need points of interest. And so what Foursquare has done, though, because maintaining a geographic database is very complicated, is that they have open sourced their points of interest. And so just to give an example, and we'll see how well this loads up. We'll just reject all cookies. All right, so there we go. We have a heat map now of over 100 million points of interest of places all over the world. And so this is like super, super useful to us because it allows us in many respects to kind of drill down, see what's there. It covers many, many different types of places. Things from like just like bus station stops to cafes to museums to hotels and libraries and all kinds of things that you might be able to imagine. And you can see for a huge portion of the world, this data set is extremely comprehensive to the point where you can pretty much tell where humans are inhabiting the planet. Oh, that's kind of funny. A little bug with Australia here. It shows in the one Australia, but not the other. So you can basically see where humans are inhabiting the planet based off of this data set alone, which is kind of cool. So very interesting to dig into. And again, this isn't a huge data set. It's not as big as you might think. If memory serves, it's about like 20 to 30 gigabytes of data. So something that can fit on a traditional hard drive can fit inside of a SQL database or something like that in a fairly straightforward way. So very cool. And we'll get into this. And just kind of backing up for a second, kind of what does this data schema look like? And when we talk about the schema, we're really talking about the types of data that are contained within this database. Unique place ID from Foursquare, not exactly surprising. Latitude, longitude, it's a geographic data set, so that's important. Names, addresses, regions, postcodes. This is actually technically also covers our time series too, because we do have dates associated with these. So date created, date refreshed, date closed. They have links to websites, Instagram and Twitter, which is also very nice. So we have just a lot of stuff that we can dig into with this, which is awesome. The other portion of this is that, and I wonder if it's here, there are also like categories. Categories are really useful. So each, all these data points, all these places, these points of interest are categorized as well. And one thing is, I think, is we'll dig in and is we'll see that for a lot of this data, it's probably going to be extremely messy. A decent portion of this is going to be straight up human entered, and people will kind of throw all kinds of stuff in any of these systems. Another portion of it is, I'm sure they are also pulling from various like data sets, whether it's census information or other things like that too. But again, those are all sources that are going to be very messy. And it'll be interesting to see as we get to this point and how we dig into this, like how this actually like all kind of comes together. So we'll see. I have this downloaded. I'm pretty sure I have this downloaded at the moment. I'm not going to be digging into this right away, right at this moment, but just to kind of set our sights on like where we're headed, what we're doing. Okay. I mean, yeah, this is just, God, just looking at this is just, I could look at this for hours, this alone, and this is just a heat map. Really fascinating. Even like digging into, from a geographic perspective, how much retail and dining there is in any given place. I'd be interested to see, so one of the things digging into this data we might be able to start to find is just like, okay, where are the most cafes on the planet? Is that of interest to us? I don't know. Where are the most retail establishments, the most travel establishments? A lot of really interesting stuff here. And one thing, another thing we'll see here, and I'm guessing that these, other than St. Helena and Ascension, are kind of probably just miscategorized. And again, we're probably going to run into fuzziness in this data set, which is fine though. I think most realistic data sets are not going to be perfect. You do see some things here where there are just like straight up lines, which doesn't exactly make sense for a geographic data set. Like here, yeah, like there's a line going through Tibet and Xinjiang that is like straight north-south. I highly doubt that's accurate. I'd be curious to see like why that's happening, and that's a question we may be able to answer, is why are there like something, is there something like this in this data set? It probably has to do with, if I had to guess, like a data import or something. That is just like where the latitude and longitude is not actually accurate. But we'll see. All right. So we will come back to that. But for now, back to coding. We have a front end, we have a back end. So let's start to combine those. Okay, and I have my editor already open, so let's get into this. So right now we only have a single kind of backend route, this ping route, which does absolutely nothing other than just returns the message Pong. That's fine though, but let's start to put this together a little bit. I'm gonna go in my app, and let's just make sure that we can connect the back end and the front end together. And this is like, I feel is like just one of those things, you always want to, at each step, you just want to verify that things are working. And then once you verify that it's working, you're generally going to like throw it away in any case. So let's do that. Now, in Next.js, so we're always going to be looking at documentation as well. Let's get static props. And this is just one way to fetch data in Next.js. We're very much going to be getting rid of this as time goes on, but this is fine for now. So, all right. Now, what getStaticProps does is basically on page load, it allows Next.js to pull in data. So we're doing this export style of build. So what this means is like getStaticProps will actually run at build time rather than at runtime. So when we build our application, our front end, it'll get this data. And what we'll see is that we'll probably be using a mixture of getStaticProps versus doing straight up like client side fetching of data. So in this case, they're using fetch to fetch information from the back end. This is an absolutely a fine way to do this. So when it comes to like live querying of data, we'll be doing the client side fetching. When it comes to things that are more build time, we'll be doing the getStaticProps. For now, we're just going to do getStaticProps. It's straightforward. It allows us to test this, in a fairly reasonable way that things are functioning as expected. All right, so let's go ahead and do that. What I'm going to do, again, we're not copy pasting. I try to avoid copy pasting, but retyping is not a bad thing. So it helps to make sure you get it right. So let's export const getStaticProps. With Next.js, it has to be that name. If you don't have that name, it will not work correctly. So we're doing an async function here. And really this is super straightforward. Const. So our backend is sending just something with message, so we'll call it message. That's just fine. Really no problem there. And we're going to await fetch. Okay. In this case, it's calling a remote API. We're just going to be calling our local API. And looking again at our backend, we don't have like anything set up here. It's just going to be using defaults. So what it'll be is we'll be at http://localhost 8080 and then /ping. Okay. They're doing the semicolon way here. We're doing semicolons. Just a difference of opinion in how to write TypeScript or JavaScript. So we have JSON, so we do need to do this. Since that's just going to be a straight up response, we'll do that. Okay, so we're getting our message, our JSON from the message back. This is just going to automatically extract everything, we're going to type this, but let's just go ahead. So when you're doing get static props, you do a return, and you do a dictionary. The props key will become the actual props for the React component of the page. So really, message here. And here, I'll just do this just to make life easy. Oh, there we go. Message here will, in the props, become the message prop. So I think we should be good there. We're going to do a type, and just to make this similar to what they have, we'll put it above. I've always had a tendency to put it below, but either way is fine. So let's get our type here. Type message. Message string. Okay. So we have our TypeScript type. Based on what we put in our backend, which we're just having a dictionary here with message, with the key of message, the value of Pong. So just to keep those the same, we have message. Message is a string, sure enough. And then we have now the prop coming into the page, that's message. Just finishing this up. We'll do the satisfies because we want the interface. And we are missing this. So satisfies. And we're going to need to import the get static props type. Get here before I do that, let's just do that import type get static props next. Okay. I'm not sure why my editor is not liking this. It's probably fine. Probably just has to do with editor configuration of some kind. Okay. Message. All right. I think we're pretty much good here. Well, also let's do make sure that the I don't know if we need to really infer get static prop type. We can add that here in just a second. This should be good for now, and hopefully will just work and will be enough for us to test this quick. So npm run dev, npm. I don't think I have the dependencies installed. I'm using a different computer. No, maybe I do. So it's npm run dev. Okay, cool. And we also need to run our backend. So I'm opening up another console tab here. And I'm going to do this. So that would just be go run. And indeed, we're using the default port of 8080. And we're already running. So we do probably want to do like a console log or something like that, just to make sure that this is actually working. So console.log message. Okay. Let's try it out. Localhost 3000. Oh, all right. So we can't use the app component for get static props, which is fun times. This is just a underlying restriction in next.js. There are reasons for that. Basically, the app runs before get static props is ready. So what we're going to do is we're going to need to make a new page component for all this. So let's go ahead and do that. So project structure. The way you do this is that we're going to create this pages directory, which will allow us to make individual pages. So we're just going to go ahead and do that right now. So, new folder, pages. And again, we're just kind of doing this live. Things oftentimes can be a little bit of a train wreck and all over the place when we're developing. I feel like it's pretty common to like run into roadblocks like this. You know, so you're just flipping between documentation and just building things as you go. So routes. Well, let me see here. So pages router. So I'm forgetting exactly. I think we want pages like index.tsx is what we're going to want. So this should be our index file. And so really this is our page template. So like it'll like the page will go inside of the body, which will kind of come down here and you'll get a page. But we need to have like define what the content within a page is. So we're just going to take this out from here. Boop. Throw it in there. Again, hopefully this will work now. And this is always interesting to see. Like, you can always just put props here if you want to actually see what the props are like on any given component. So it does appear to be running still, so that's good news. Okay. So that console log is working, and so we are getting the actual props for this page. Now we're going to need to do a little bit more to make sure that that page template is working appropriately. So we have params. Is always fun getting like resource IDs and stuff. Those tend to not be super useful. What we probably need is the children, if I had to say. Children is just what's going to be the kind of within the component. Let's see. So we're going to destructure that. So what this is doing is this is the same as if we do children here. This would be the same as doing if we do props here. And do props.children. Let's see what that is. Let's see if that gets us anything. Oh, it's actually undefined. That's kind of interesting. So I'm not even sure this is the page.tsx is necessary. Return. So we're just going to do this. This is going to be a fragment. When we're doing JSX, which is like just the JS HTML love child that that React uses, we always need to have some kind of element to put it in. If you don't want an element, you just do a fragment. So it's just angle brackets, basically like it's an HTML element with nothing. So like an empty HTML element. Okay. And again, we're not getting anything here. We'll just take this out. Let's see if we get anything here. Just do children. So we're just kind of console logging our way through this. Getting nothing whatsoever. Which means that that component is not getting called. So let's go back to the documentation. I'm surprised here, like I'm decently experienced in Next.js. So I'm kind of surprised that this isn't working. Route files to name index at the root of the directory. So pages blog / index.js this should work. Maybe I'm just not doing this correctly. One thing we can test here, maybe it's just like this page will be the root page or the index page globally. So let's just do a test one. Sometimes this can get results. And that one is just not working at all. which is interesting. We did call it pages. That's good. We do have app. That's good. So we're missing something. Something is not right about this. So let's go back to project structure. App router. Yeah, that's what we want. Pages router. So we have two routers. I wonder if like there's just a difference here between the app router and the pages router that we're not understanding, or I should say that I'm not understanding. The router automatically route files name index to the root of the directory. Pages dynamic routes. So we don't have any dynamic route here, so we don't need to worry about that. Layout is fine. Well, this is interesting. We are returning something. We can just try returning a string. As far as I know, this should be working. But it is not. Let's restart the dev server. I don't think this is it. Oh, no, that is it. Okay. So our issue is that Next.js just was not picking this up and we need to restart the dev server. So let's try and actually move this back into pages, because this might actually work now. Oh, okay, so we don't want to use the app page. Those are technically conflicting. So we'll just get rid of this. And so sometimes you'll find that. Sometimes with everything, computers and devices, just restarting things does the trick. And so we restarted it, doing the trick now. All right. So now we're actually using, so we have a layout under app. It's not using that general page layout, which is good. Let's see if we can like console log. Console log children's getting us nothing. But let's see. We might be getting our props though, as we expect. Nope. Don't want to destructure this. So destructuring means we take the keys of an object and just extract them into separate variables. We don't need to do that in this case, or we're just not going to because we want to actually examine and see what's going on. Oh, there we go. So indeed we do have the message, and message Pong. So okay, message. So we're going to destructure this, but remember we have actually another message within here. So it's going to be message.pong. We haven't like typed this to death, so we're not like getting a whole lot of type assistance at the moment. Oh, message dot not pong dot message. Hey, there we go. And so now we are successfully getting information from our backend. If we were to go, and you know, I think the Go things are going to keep playing with us for a while. Change this here. Naturally, this is Hanuman, so let's change that. Again, with our Thai language. And of course I'm going to forget the spelling. Let me go back quick. Make sure I get the spelling right. Okay. Go back into the back end. And we got who on. Okay. I think I got that. Which? No, not quite. Always check your spelling, folks. There we go. And it's going to redo all this. That message. Should we save this? Now, granted, we just need to restart this quick. Okay. Hey, it's working. So now we are getting an actual dynamic response. Well, kind of dynamic. It's static on the back end because we've compiled it statically, but we are have an actual like communication between the front end and the back end. So let's go ahead and commit our changes then. So we're going to do that. Do that. Still do an English commit message update. Front end to pull data from back end. Okay, cool. This is just stuff that Next is doing for us. So let's just do next.js updates. Commit that. We haven't pushed yet. And then update Hanuman ping message. Okay. So we'll push all those changes. Okay, progress. We're getting somewhere, slowly getting somewhere, but that's okay. So one thing you all may have noticed, and this is kind of the case in dealing with any compiled language like Go, C++, whatever it happens to be, is that we made changes, but then we had to go back and we had to restart everything. So that can be like a little bit of a pain. And so I think what we're going to want to do is use actually some kind of Go project here to basically to live reload things so that the compile process will rerun when we make changes. This is super helpful, and what it does like primarily is like we're taking out a source of error, like, and just kind of making our life easier. So rather than having to like rerun everything all the time, we're just going to have to like make changes. It'll automatically rerun and recompile. Now, ideally too, we're going to try and keep everything really slim. So as you've noticed, the Go run is quite fast in the first place. Like we're pretty much getting to like this running almost instantaneously. So we're going to try and keep this quite slim and hopefully keep that pretty like instantaneous experience. So here, Golang. So usually, yeah, you'll see this like hot reload or dynamic reload depending on who does it. Yeah, I mean, they're calling it live reloading, hot reloading. Same kind of thing. Ooh, one sec, guys. My vacuum, it was that time. The vacuum is turned on. 1 second. All right, vacuum gets to take a break for today. Always good to give the robots a little breathing room. So, oh man, this was actually written specifically for use with Jin in the first place. So that's nice. So let's see how we use this. A lot of different ways, a lot of different methods that this can potentially be used. Always kind of can be kind of fun to get these running. So they just recommend using go install. Again, like, I'm definitely for not copy pasting code, but I think commands, as long as you're understanding what those commands do and verifying the commands before you actually run them, is not a bad thing. So let's see. I don't know if this will just work. Yeah, I'm not sure if I have the Go path configured correctly for my environment. Things like that, like paths and stuff, it can really be kind of a pain. So let's see. Yeah, I'm pretty sure it's just that's the issue here, is that the Go binary or the Go executables are not in my path. Which by default, I'm trying to remember where these actually end up. The good news is I don't think it's in here, so that's positive. Okay, so it's home/go/bin. That makes life a little easier. Now we're just getting into like a little side quest here. I'm going to so this one is a Rust one. I think we can just use the dot. I'm not sure though. So basically, we're just adding this path to the environment variable, the path environment variable. So let's go bin. That's functionally what we need. No, zshrm. I think that's the wrong file. I think it's on macOS. It's .z profile. I'm using ZSH. So this is specific to the shell that you're using. And as you might have noticed, this is something I don't do too often, and something that really oh, good old Stack Overflow. Okay, here we go. I'm just using Vim, longtime Vim user. Basically any editor is fine though. So we'll just go here, export path. It's going to be home go bin, and that should do the trick. We may need to like reopen this. I'm going to go and also undo what I did with the zsha file. That's just editing the environment. I don't think we need to do that. So just to make sure, source will actually just run this file again. Let's see. Okay, that works. So what we're doing now instead is just simply running air rather than go build or go run dot. And so let's see if this works. This is cool. Okay, Hanuman.go is changed. Building running, that is what we want to see. Hey, okay, good. So we're making progress. We have the live reload for our Go backend now. We do need to provide some instructions though. So let's do that. Okay, readme. For live reloading of the Go backend, air. Okay, so we're making progress here. We have live reloading for the front end and for the back end. Now, one other thing that folks may have noticed is we have to have these two separate tabs for running things, which is kind of a bummer. So I think the next step to do is just making sure we have some kind of process manager. So what that's going to do is basically it'll run npm run dev and also run air at the same time. So there are a lot of ways to go about this. We're not going to be using PM2 is for process management in production. We don't really need that, I don't think. That's probably going to do more than we need. PM2, yes, absolutely just overkill. Dev process manager. This looks like it could do the trick, although it's basically hardly used, which is, not great. We all have to start somewhere, but we probably want to do something a little bit more than that. I guess we could just use PM2, but PM2 is like really specific to Node.js, so I'm kind of hesitating to use that. Let's just try this process manager, and again, there's so many projects out there that you could potentially use to do this. I'm just trying to find one that will kind of work in this scenario. So React front end, Golang back end. Golang, creating React front end for a Go API. Oh man, we're kind of not getting anywhere at this point. And again, we kind of just want to have a command to run things rather than having to, you know, oh man, yeah. So yeah, NodeMon. NodeMon's another one. Supervisor. I don't know if I've used supervisor. We don't really need NodeMon. Next.js already does the rebuilding, and so Air does too. PM2 actually, from this perspective, might actually be a good choice. But let me look at like supervisor, just because I really don't know too much. Okay, yeah, we're not. That's not just general supervisor. Process manager. This is probably more than what we need. Since we're doing a JavaScript based one, I think I'm just going to go with PM2 for now. It might be like a little bit on the heavy side, but I think it's okay. PM2, I've used it in the past, and like it's fairly straightforward to use. I've never quite used it as like a dev tool, but that being said, why not? It can manage processes together, so I think this will do just fine. So let's go ahead and do this. And so this is like one thing I feel like at the beginning of any project, just getting these things set up tends to be a little bit time consuming, or it can be, but it's usually worth it like down the road, because it makes lives easier for people. So the less you have to do in order to like get an environment running or working, usually the better. I've seen like make files and stuff to do this, although make is like very old school and kind of clanky and maybe a bit janky. This is probably, yeah, I mean, PM2 has like a pretty nice interface and such. So I think we'll be okay with this. And I believe you can install PM2 as a project dependency. So we'll do that. So it'd be npm install PM2 save dev. So we're going to install PM2 as a dev dependency. It just means that it's not actually needed for building our application or for like an actual like runtime dependency. It really is just for development. We'll check this out. I think we'll be okay. Okay, we got PM2 there. So can use, okay. An easy way to do this might just be the module exports this ecosystem.config.js just to make life easy. So that way we kind of can get a nice interface here. The nice thing about PM2 is it actually does work with Node.js stuff as well. So okay, let's just try this out. I'm going to go for the ecosystem.config.js route just to make life easy. Ecosystem config.js module exports. So we're just going to have one key here, apps, which is an array. We only have one app in this case. Well, we have two apps really. So our command will change to this pm2 start ecosystem.config.js. Let's see if we have ecosystem. I thought there was more. You start trying to use cluster mode. Oh, there's that. You can start do a static file serving too, which is nice. Exposing RV metrics, monitoring, daemon, multiple PM2 module system. We're kind of getting into the weeds here a little bit, so my apologies there. Be interesting. I think we don't need to worry about the script. I think we can just basically use the node scripts there, but we'll see. So name, well, here we go. Next.js. And so this should, I'm pretty sure we can just do next to dev in this case. We'll see if this works. Always fun to go into the weeds here. Name, let's call it backend. We don't really need to specify it's Golang script. There, I believe this should work. If memory serves, and it's been a minute, so we'll see. Yeah, it shouldn't be. Can test this. We can just create a new script. We'll call it PM3 PM2 dev. So it'd be, we just want to run the PM2 command from this. So it'd be. I believe it's PM2 start ecosystem. Let's try this. So, okay, cool. We're not running anything. So npm run PM2 dev. Great. We don't have PM2 installed globally. So it didn't like air, but it did appear to actually run the Next.js dev, so that's good. For now, we don't really want to install PM2 globally, so let's just throw in here. This just makes life a little easy. All right, so PM2 list. No, I'm not exactly sure what's going on there. Didn't like the ecosystem config, maybe? Interesting. No, it's not there. If I could read, it's actually the package.json that is messed up. I am missing that. Is it that? No. I am missing something in the package.json. There we go. Okay, cool. So we can see that it is actually working, which is great. PM2 stop. I think we gotta do this. Ah, damn. I always forget how to run like scripts through npm, which you need to do just to make sure the environment's correctly when installed locally. So I think what we'll do is we'll do dev start here and dev stop. So PM2 start eco. Okay, so this is gonna, the dev start is gonna fail for now because it's not gonna like air. We can check though that things are running, and we can do dev stop. Okay, so we have things generally working here. We just need to get air running too through PM2, which is possible. So let's do PM2 run command. There is a way to do this as I've done it before. I feel like rather than script, it's something else. PM2 run non-node process. We'll see. We're going through like all the Stack Overflow type sites here. Oh, here we go. Start any process type. Oh, that totally didn't work. Did they? Wonder if they removed things. Cluster mode, ecosystem file. We really don't need an interpreter or anything like that. We just need it to start here. PM2. All right. Making very little headway at this point, which is always good. PM2. Manage. Let's try this. I guess interpreter just might be the command, so we might just be able to just immediately run rather than script here. We can do interpreter. This feels kind of funky, but still might work. Script, it wants a script path. Good Lord. Oh, being dumb. This is not JSON, this is JavaScript. So those quotes were totally unnecessary. Oh, we don't have air in this terminal instance, so I just need to source this quick. Which air? Oh, there we go. I think we're in business now. So if we okay. 8080 ping. Okay. Everything appears to be working now. It's a little kind of a funky way of doing this. but it'll do the trick. It does give us a nice way of just kind of monitoring these things, and so that is very nice actually. So when we're running the dev environment, it will run in the background, but things should just recompile. Air and Next will take care of that. We don't need to do anything for our PM2. It's really just starting everything together and giving us a kind of a nice interface to use when doing development. So progress, slow, sometimes pain in the neck progress. We do have another temporary directory here we're going to want to ignore. So updating the get ignored to air, yes, air, compile directory. Let's temp. We may want to change that in the end. We'll see. And let's just see if we can do the one thing that is nice. We may want to actually be able to access logs. So editing our scripts real quick again. Dev monet, PM2 monet, easy enough. Try that. So npm run dev monet. Oh, cool. Not showing any logs, even though I feel like they probably should be. That's a bit unusual, but that might just be a setting with how PM2 is configured, and the actual where the outputs are going for the Next.js and through Air. Let's look. We'll try the dev logs. We may get nothing, but we'll probably leave that as is for now. So dev logs. So PM2 logs. And we'll get rid of this and get rid of that. Dev logs. Oops. There we go. Okay. Cool. We are getting logs from Next.js and from Air. And we can see. We'll do this and we'll see if this actually updates. I really don't know if it will. It may or may not. Oh yeah, no, it's fine. So we are getting logs out, which is great. So I think this is probably a good place to wrap it up. Let's get all these files. We'll probably need to update the README some still, but we can save that for next time. And okay, let's do this. Update README. Get ignore for Air. Okay. Commit that. And use PM2. Okay, cool. We'll push that. And I think we're all good to go. So that is it for this time. We kind of went through the architecture, everything else. My fiance is home, so this is like actually perfect timing. We got like our development environment set up more. We connected the front end and the back end, defined what we're doing, set a target data set that we're going to be working with. So this is good progress, and we'll keep it rolling until the next one. So see you guys.